In the conceptual video, you learned that acceleration is a change in velocity per time. For us, that's going to make an equation that looks like change in velocity per time. Because we know what to do with a delta really means the final velocity minus the initial velocity over time. So this is our definition of acceleration. And we are going to be using this equation to solve quite a few problems. Let's do an example really quick. A car is moving along a straight highway. Then the driver puts on the brakes. If the initial velocity when he hits the brakes is v0 equals 15 meters per second, and it takes 5 seconds to slow down to v final equals 5 meters per second, what was the car's average acceleration? Once again, let's identify our knowns and our unknowns. So we've got that v0 is 15 meters per second. 5 seconds would be our time. And v final is 5 meters per second. What they're asking for is the car's average acceleration. So we'll write that here with a question mark so we can keep it all straight. And sure enough, this relationship up here covers everything. It's got everything that we have and the thing that we want. So let's write it down here. And we're just going to substitute the numbers in. So my v final is 5 meters per second. Okay, I want that to look like a period. There we go. Minus our initial speed, which is 15 meters per second, over a time of 5 seconds. And what that gives us is an acceleration of minus 2.0 meters per second squared. Now let's talk about this minus sign. The minus sign means that we're accelerating in the opposite direction that we were moving. What it doesn't mean necessarily is that we're slowing down. This is so confusing to people who are learning this for the first time. In this case, since we're moving in the positive direction, having an acceleration of minus 2 meters per second squared means that our speed is dropping. We're taking away 2 meters per second of speed every second. However, what if we'd been moving in the opposite direction, moving in the negative direction? If that was the case, then an acceleration of minus 2 meters per second squared would mean we'd be getting more negative, or what that really means is we'd be speeding up. Okay, so what's confusing is that this sign doesn't necessarily mean slowing down. How can you tell if something's speeding up or slowing down? Speeding up is when the sign is the same. Okay, slowing is when the signs are opposite. You can't just say negative acceleration means slowing down. In this case it does, because we're moving to the right or in the positive direction. Again, if we had been moving in the opposite direction, that would mean speeding up. So we just have to be careful with that. What you're looking at right here are called the constant acceleration equations. They're a group of equations you can use to solve problems of motion when the acceleration is constant, which is most of the time. Now, if the acceleration is 0, these are completely unnecessary. If you're moving at a constant speed, all you need is that speed is displacement over time, or distance over time, or velocity is displacement over time, but you wouldn't need those. But in the case where you are speeding up or slowing down, these are super handy. And what you may notice here is that inside here, there's a little grid. And up here are they're the 5 different variables that show up in these equations. Every one of these equations has 4 of the 5 and is missing 1. So the way we apply this is we look at a problem, we figure out what we know and what we don't know. And inevitably we'll wind up knowing 3 things and be looking for a 4th. And then the 5th will just not be present at all. So the way you pick which equation to use is you figure out what you know, what you want to know, and whatever isn't mentioned, you look for the one with the hole in it, and that would be the equation you use. You're designing a runway for a plane that must reach a speed of 27.8 meters per second before liftoff and can accelerate at a rate of 2 meters per second squared. What minimum length must this runway be? We're going to find all the numbers that we're given and figure out what we need to find. So we've got a speed here of 27.8 meters per second. Now the question is this our initial or final speed? Well, if you think about it, this plane has to get to that speed in order to take off. So this is our final speed. And the next number I see is an acceleration rate of 2 meters per second squared. So I'm going to write that. And finally, it says, what's the minimum length of the runway? That's a length. That would be our delta x. Now, it looks like we have a problem here. It looks like we only have 3 total variables. And this is something that's going to show up a lot, which is, where's the other variable? You notice time isn't mentioned anywhere. So what's left? What's left is the initial speed, and they don't mention it. But you have to assume that if the plane is taking off, it's taking off from rest. And so we do have the initial speed. It's 0. Oftentimes zeros are implied in these questions. They're not stated. Sometimes they would be. It could say that it needs to start from rest, which is a clue that means that you're starting from 0. But in this case, what else can we assume, honestly? That's what we have to do. Now, if you look, I've got v final, acceleration, displacement, and initial speed. What's the one that isn't mentioned? Time. So time is not mentioned whatsoever. So I'm going to go down and look for the place where there is no time. And lo and behold, I have this equation here. So this is going to be the equation that's going to help me get my answer. I'm supposed to find delta x. So the next step always is solve this equation before putting numbers in it. That's really important, you guys, for delta x. So what I'm going to get is, first thing I'm going to do is I'm going to subtract v0 to the other side. And I'm going to get v final squared, minus v0 squared equals 2a delta x. And then I need to isolate delta x, so I'm going to divide everything by 2a. I'm also going to flip it around. So, I'm going to flip it around, and I'm going to wind up with this guy here. All right. Delta x is v final squared minus v initial squared all over 2a. And I'm going to plug the numbers in. So v final squared would be 27.8. And for the sake of space, I am going to actually lose the units. Typically, you don't want to do that, but I'm running out of room. All over 2 times 2. Gosh, I totally could have fit those units in. Okay, whatever. All right. Anyways, when it's all said and done and you put these things in the calculator, what you should come up with is 193 meters. Ta-da! So this is how you use these equations. You can solve for any variable in any of these equations, and you just have to figure out the method for picking the right one, which we just went over. All right, good luck.